All right, hi everyone. Today's notes is going to be about climate change. So we're going to cover a lot of different topics through this. So let's go ahead and get going here. Now, full disclosure, climate change is happening. There's lots of scientific evidence that it is happening and that human activities are accelerating that process. So that the theory of global warming is very sound. Now, there are a few areas of active research that we're still looking at. Number one is how fast and how much the temperature will increase, as well as rainfall levels and the severity of storms. So again, the research is kind of showing that those things are going to increase, but we're not really quite honed in on exactly how much. But despite that uncertainty, all of the scientists agree that it's much more risky to do nothing about it. Now, remember, we looked at proxy indicators. Proxy indicators show that climate change has happened in the past, right? So Earth's climate has changed multiple times throughout history. But you can see here that the most recent uptick is right here at the end. So we have been warmer in the past for a variety of different reasons. Volcanic activity, burning of coals, the Milankovitch Cycles cause a cooling cycle in the Ice Age. But again, we're having an increase of temperature right now, and primarily because of CO2. So climate change has happened and is happening, right? So climate change is a normal process. The goal is to understand why it happens and how it will affect us. Okay, so that's it. Now, the other thing with this too is the Earth's going to survive, right? The questions are more to do with how will the Earth change, right? And how the organisms adapt, including ourselves. Now, there are a few different causes that cause climate change. There's long-term and short-term. Long-term causes are continental drift. So the continents shift all over the planet, and that obviously is going to have an impact on the climate because they're changing positions, which impacts weather, which impacts climate as we go through. Now, currently we've got good circulation because of where the continents are, but that has been different in the past, so where you don't get that distribution of energy quite as efficient as it is. So for example, right now we've got the Gulf Stream that kind of brings that warm water up from the equator to the northern part. So the placement of the continents is one thing. Another long-term is astronomic. We looked at this. This is those Milankovitch cycles, right? So how the Earth is oriented, how it rotates or orbits around the sun, that is going to have an impact on climate as well. But again, it's long-term, right? So we're looking at in the scales of tens to hundreds of thousands of years. Now, going to short-term volcanic activity. So volcanoes spew a bunch of material up into the atmosphere that can have a cooling effect, right? So Mount Pinatubo, when it erupted, the next year we had decreased temperatures because all those particles in the air blocked the sun. Another short-term one we've talked about is albedo, right? So the presence or absence of substances that have high albedo, snow and clouds, that's going to have a short-term impact on our climate as well. Right? And that leads to those feedback cycles between global cooling and global warming. So we're currently in global warming right now, and the main driving factor behind that is humans. Okay, so this is another short-term cause, and they call it anthropogenic. It's what we are doing that causes it. Now, throughout this, we're going to look at some things that commonly here, and we're going to try to address them. So we've heard that climate has changed in the past. Is it currently warming right now? So in the survey, I asked you guys at the beginning of the unit to fill this out, and overwhelmingly, you can see here the top right there. Most of you believe that it is warming. A small percent believe it hasn't, and the bottom left there shows the graph of kind of where Americans feel. So you guys are kind of on about the same page. But here's the data, right? Data collected by climate scientists shows the planet is warming. Okay, so we have a large database of information that shows that the climate is warming, and we're seeing consequences of just a 1 degree increase in global warming, and we're seeing impacts of that or the effects of that. So you can see that graph there is showing the observed monthly average global temperature. So we're not talking daily; we're doing monthly averages, and you can see that has been just increasing. That's just clear that's what the data is showing. So the planet is warming. Now that data is all coming from this thing called the IPCC. So who is IPCC and why should we listen to them? It's the Intergovernmental Panel on Climate Change. And it's a leading international body for the assessment of climate change. So they're not related to policy. They provide information that policymakers can use, but they don't prescribe policy. Now, all it is, it's a group of climate scientists, right? There's almost 500 lead authors. There's 800 contributing authors, and then there's over 2,000 experts that review the documents. And that's the key thing here, is that scientific review is an essential part of this process. So they are not just willy-nilly kind of putting together information. All of the stuff that is the IPCC puts out is stuff that has been reviewed in peer-reviewed journals, right? And it's been looked at multiple times to ensure that the information that they're putting out is accurate, right? As accurate as it possibly can be based on our current understanding. Now, even with this, you still have people that are skeptical, right? So you'll hear sometimes, well, I heard that in the past 10 years, the temperature's actually decreased. You got to be careful with selective data. That's kind of what we're going to look at. The graph up to the right here above me is showing that if you selectively choose certain dates, so for example, in 1998, we had an abnormally large El Nino, which meant the Pacific Ocean was abnormally warm. And you compare that then to about 2008, where we had kind of cooler temperatures. Yeah, over that time span specifically, there was a temperature drop. But what the IPCC does and scientists do is we look over the course of decades. We don't look at specific dates. We compare large scale changes. And over that, each of the consecutive decades, we have an increase in temperature. Now, here's another one too, right? Well, it actually decreased last year, right? It's saying it was cooler last year. Again, be very careful of selective data. When we're looking at climate data, we're looking at global averages. We're not looking at specific locations because the planet is very dynamic. It is going to have some places that are different, right? It's going to be variable. So that's why we look at the planet as a whole. Instead of finding very kind of like specific data. So again, IPCC put this report out that each of the past 3 decades has been successively warmer. Since 1850, you can see that graph there going, showing that increase in temperature. Now, here's another thing that sometimes you'll hear: the climate's warming, that's normal, right? And we even said it, right? That climate change is normal, so we don't have anything to do with it, right? Well, so I asked you guys this questions and asked, do you think that climate change is caused by things that people have done, if it's natural causes or a combo of both? And you can see about almost half of you think it's caused by people. About another, not quite a half, are equal by both, and then a smaller percentage called by natural. And you can see the U.S. respondents, 80%, right, feel that it's caused by human actions. So again, back to the IPCC, what do they put out in their published report based on the thousands of peer-reviewed articles that they've looked at? And they say it is extremely likely that we, being humans, are the dominant cause of the warming since the mid-20th century. Okay. Now, they can't say 100% just because in science, right, we try not to say that, but if they say it's extremely likely, that is a very high degree of confidence. Now, what is this all coming from, right? Carbon dioxide from coal, petroleum use, right? So when we're burning gasoline, that releases those greenhouse gases, slash and burn deforestation, right? There's lots of countries that do this to get farmland. And what that leads to then is, you can see over the past 800,000 years, there has been kind of variability, but you can see at the far right part of the graph there, we are at the highest levels of CO2 that we've had in millions of years. And it's not just the height or the amount that we have, it's the rate. It's very quickly accelerated. And again, we're associating that to humans. When we started the Industrial Revolution, we started putting a lot of CO2 into the atmosphere. Okay. Now, the other thing we'll say sometimes or hear is that, well, it's a debate, right? I saw this report in the news that said it's not really something to worry about or not. And so I asked you guys, what do you guys think about it? And Wheat North students, about 77% feel that scientists agree. 23% of you feel like there's some disagreement. The national average is about the same with this. But here's the deal with this. Like if we look at scientific organizations that hold the position that climate change has been caused by human actions, it's a really long list. Scientists agree. It's in the 98 to 99% of scientists are on the same page with this. It's a very, very small percent that have some type of issue or problem with it. But you may even say, well, so what if they agree about it? I don't think it's anything to worry about, right? Who cares if it just gets a little bit warmer for us? So again, I asked you, do you think it's a problem or not? Most of you said it was a bad thing. Some of you felt it was like, well, neither bad or good. And small percent of you, maybe you like summertime and you want those warm temperatures. You hate winter with this. Here's the deal with this. We kind of have to look at this from a different lens. We have to look at this from a little bit more of global human socioeconomic lens. That's what we're going to look at it through. So what we look at is based on like healthcare and food supply and how stable a government is. The U.S. is very stable along with Europe, and you can see a lot of countries in Africa are not stable. They're more at risk because of this. So as an example, Malawi, you can see that they're at a high risk, but they only produce 80 kilograms of CO2 per year. U.S., because we're very kind of well off, right? We're not really at much of a risk, but we produce tons and tons of CO2. So the countries that are really not at risk are really the ones that are producing the most CO2. So it's kind of mixing, is a country vulnerable? Are they exposed? Like, are they in a part of the world where they're at a higher risk? And then you bring those weather and climate events in, and that kind of is how we assess if there's a disaster risk at all. So projected climate changes that we are anticipating: oceans are going to continue to warm, right, which is going to result in sea level rise. Oceans are going to become more acidic because as it absorbs that carbon, it's going to lower the pH. The Arctic ice cover, the ice sheet up there, is likely going to be disappearing and melting. And then, like we talked about in class, the glaciers are melting. Now, how is that going to impact us? There's a few different things, right? Number one, we're expecting, because of these changes, food and water shortages. Again, maybe not for the U.S., but those countries that are really at risk. Increased displacement of people, right? A global temperature increase of 4 degrees is more closer to 10 to 12 degrees when you're on land. That ocean acidification is going to hurt the base of the food chain, right? All those little microorganisms that then feed the bigger ones, we expect that to be impacted, which all of this will kind of lead to increased poverty and potential coastal flooding. So looking at coastal flooding, this is, again, data from the IPCC looking at how the sea levels are rising, right? There's no doubt about that. And with sea level rise, there's really two parts to this. About half of it can be attributed to melting glaciers, right? So that's going to add water. The other part is, as the oceans warm, they actually expand. And that can cause sea level rise as well. So we're expecting 3 feet of sea level rise in the next 100 years. And then the ballpark range could be at the best estimate, or the best case scenario, 1 foot all the way up to 6 feet over the 100 years. And then the other problem with this too is, remember we did the specific heat. Water's really slow to react. So once it starts heating up, it's going to take a long time to slow down. It's like a freight train. So here's current Florida. This would be kind of what we're mid-range expecting, and then this would be the worst case. So the area you see in the red there would be underwater. So a lot of Florida would disappear. That would be worst case scenario. Again, currently estimates, and then worst case scenario. Here's New York, same thing. So you can see that's kind of a concern. So the IPCC always kind of does best case scenario, what we're on track, and kind of worst case, to kind of just give us that range to see where everything is. And right now we're on pace right now for a 4-degree increase, which is bad. Okay, that's not going to be good for anybody. What we're trying to do is we're trying to mitigate to get to 2 degrees. So there's no way that we're going to stop global warming from happening unless we make drastic changes. What we're trying to do is just make it so it's not too bad, right? So the planet and the climate is going to warm. We just want to prevent it from being really, really bad. Okay. All right, everyone. A little bit longer than I'd like, but again, a lot of information there. Let me know if you have questions. Have a great day.